1, which is dealing with polynomials. So chapter 4 will deal with variables and expressions and all these other fun stuff. But we're going to start off with polynomials. And let's look at some of the vocabulary that they're going to introduce here. We should know what these terms mean. A monomial is a single expression, variable product of a constant and one or more variables. So we can have it as a constant, which looks like this. This is a number or an integer or a decimal or anything of that nature. Or it can be just a single variable, or it can have a variable to an exponent with a coefficient. That coefficient is -1. The exponent is 2, or it can have all those components. It can have a coefficient, it can have a variable, it can have an exponent, and it can actually have 2 variables. So those are all monomials. Coefficient is going to be the number in front of the variable. -2, for instance. Degree of a variable, the degree is going to be the exponent of your leading variable. And then in a monomial, so the degree of x is 2, the degree of y is 1. There's an exponent 1. There's an invisible 1 there. Degree of a monomial, the sum of the degrees. So the degree of a variable, so you would add them. So the degree of the monomial in this example would be 3. When we say 2 and 1, that's the degree of the variable. So if we have that, it's going to be 1 and 2, which makes 3. Similar, like monomials that are identical or that differ only in their coefficients. Similar, like terms. Like monomials, like terms, have the same variable. They both have m's, and to the same degree, that's m to the first, and then you have n to the second, and you have n to the second. So those are like terms. Whenever we have like terms, we're going to combine their coefficients. Polynomials, more than one term. This would be a polynomial. Technically, that would be considered a trinomial because there are 3 terms. This would be a polynomial. That's a monomial. Those are the terms. Those are the 3 terms, simplified, no 2 terms, so you don't have any like terms. And degree of a polynomial, the greatest of the degrees is its term after the polynomial has been simplified. You put it in standard form, what we call standard form. So example 1 talks about the directions say simplify. Arrange the terms in order of decreasing degree of x, then write the degree of the polynomial. So we're going to put it in descending order, what we call standard form, and we're going to combine like terms, and then it'll be in standard form after. So we see that we have like terms here. So we have x to the second with a coefficient of 1. We have x to the second with a coefficient of 2. So if we combine those coefficients, we get 3x squared. And then we have xy. So that's x to the first, y. And then we have -8 x to the first, y. So we would combine those coefficients. -8 and +1 makes -7. Next group is going to be -x and +3x. So -1 and +3 makes +2x. And then we have our constants, -6 and 3, and that makes -3. Now notice that we have x to the second, we have x to the first, x to the first. This x to the first comes first because it has a larger degree because you have x to the first, y to the first, which would make it a second degree term or monomial, and the 2x only has a first degree monomial. The greatest degree of any term is 2, so the degree of the polynomial is 2. All right, let's try them out, and let's start doing these problems. First thing I'm going to do is I'm going to write them in descending order. Some students would want to cross them out after you write them. There's not so many that I can't keep track of them. We will combine these because they have the same variable to the same exponent. So they are like terms. And when we have like terms, we're going to combine their coefficients. Coefficient is -5 and positive 5 and +3. So those are the like terms. We don't have a like term with the x to the third. That is 8x squared. And then we also have these like terms. The constants are like terms. And that'll give us -1. So our final answer, simplified, is going to be -5x to the third plus 8x squared minus 1. And then it says write the degree of the polynomial. Well, this is a third degree polynomial, or trinomial, because it has 3 terms. And that's all we're going to do with these. So we're going to do that for each of these, and we should get pretty quick about how, or efficient, shall we say, about doing them. We have like terms because they're both x to the fourth, so we're going to combine their coefficients. There's an invisible 1 there, so we have 4x to the fourth. We have another set of like terms. We're going to combine those coefficients. And then we have plus 3x squared. And that's going to give us 4x to the fourth minus 3x to the third plus 3x squared. And that is considered a fourth degree polynomial. We have 3x to the third minus x squared plus 3x squared plus 2x squared plus 3 minus 5. Doesn't have a pair, so we have 3x cubed. These are all like terms, so we're going to combine, and we get plus 4x squared and then minus 2. So number 3 should be 3x cubed plus 4x squared minus 2. And that's going to be our leading term. Our first term in the polynomial goes to the third degree. So this is considered a third degree polynomial. All right, now it's getting a little crazy. So 3x squared y is going to match up with negative x squared y. And then we have plus 7xy cubed. Now, I wrote this, even though this is a bigger degree monomial, this is x to the first, so it'll always come after x to the second. And then we have plus, oh, sorry, I messed up. I see that I should have had this, but we can fix that. We can move everything. That term definitely comes first. Negative 3x to the third plus all that stuff. That's already been, oh, sheesh. I got 2. I missed all of them. How you want that? All right, that's okay. This is why we do these, because we can make mistakes. And if we didn't make mistakes, then there wouldn't be very much learning. So I forgot that one also. And we'll make that negative 2x to the third plus. So now that's in descending order. Based upon my terms, I'm going to combine those like terms, these like terms, and these like terms. and I get negative 5x to the third plus 2x squared y plus 13xy to the third, and that's going to be a third term polynomial or fourth term polynomial? That's going to be a fourth term polynomial. Now that's interesting because that's my biggest polynomial. We have 3 and 1 there, so that's why I said fourth. So this is considered a fourth degree polynomial. And the nice thing about doing these problems is you get some clarification on what and make sure you're doing it correctly. I always was under the understanding that it's your lead term in your polynomial, but clearly that's not the case. It is your biggest degree. So this is a third, this is 3, and this is 4. So it would be considered a fourth degree trinomial. Apparently that is what we're going to do. Okay? Not many. You know, it's interesting. I don't know why they are so adamant about the degree. Don't know too many times where I'm pointing that out. I'd much rather have you focus on simplifying the polynomials. That is extremely important. I'd also definitely put an importance of putting it in standard form. That is an important thing. But knowing the degree of the polynomial, not as important. Not as, I don't really see too many questions in high school where that comes into play. So let's do this. This is going to be my first term, x to the third y squared. Then we have a matching term or a like term. And then we have this one, which is not like it, even though it has x to the third, but it's y to the first. And then we have this. We have x squared y squared. And we have negative 2x squared y squared. So like terms and like terms. So that gives us 5x cubed y squared plus 3x cubed y minus x squared y squared. And that's going to be a fifth degree polynomial. Let's make sure 5x cubed y squared plus 3x cubed y minus x squared y squared. Yes, nice. Alrighty. We're going to do 2x squared y, and we have plus 2x squared y, and then we have plus 3xy squared minus 6xy squared minus 4xy. Like terms here, coefficients, 4x squared y minus 3xy squared minus 4xy, and that's going to be a third degree polynomial. Let's make sure that's correct. 4x squared minus 3xy squared minus 4xy. Yes. Perfect. All right. In example 2, we are adding polynomials. We're adding trinomials. So we're going to add this trinomial to this polynomial. That's 4 terms. So we see that it's in the parentheses. That's the notation that we're adding. So it says to add. And so that is the notation. Yeah, I'm tending not to do this stuff. And I probably wouldn't do this either. What you'll see me do is I will write it in this fashion, but I will distribute that through. That's not very good. Let's do this. I will distribute that positive in, or at least I'll say, when we multiply anything by 1, we're going to get our starting terms. So that doesn't really do anything, but it does allow you just to open it up. It is important because when we see the subtraction, That is completely different. So we have this term minusing, this term minusing from, we see that from statement. We're subtracting, let's do that, subtracting from this. No, I don't want a green, I thought from this. So that has to start, and then we're taking this term from this. So that's why the 3x squared plus 5x minus 3 is on the right side. And then, as you see, they distributed that negative, which changed each of the signs inside there. So if we distribute, we notice that each of the signs here have flipped because we're distributing a negative. And then we're combining, and we'll get our final answer. So you'll see, pay attention to add the polynomials and then subtract them. So A, we're going to add them. So that statement would look something like this. We distributing a positive through removes the parentheses, and now we would put them in, we would match them up, and then we would combine like terms. So we get 7x minus 3. If we're going to subtract, we would have, again, the parentheses. The only difference between those is one's adding the two binomials, and one is subtracting. So we're going to distribute that negative into there. And that, again, that distribution removes the parentheses, but we need to remember we're distributing a -1, multiplying a -1 by each of the terms inside that second binomial. So it was a positive 5x, it's now a negative 5x. It was a negative 6, now it's a positive 6. And then we're going to rewrite them with like terms next to each other. We get negative 3x plus 9. And I think that that is all it's asking for. It's not asking for anything more than that. Let's look at answers. Additional answers are given at the back of the answer key. That's not very helpful book. So let's look at the answer key, find the extended answers to that, just so we can ensure additional answers. And we are chapter 4. That's exercise. How do I know chapter 4? There's chapter 4. Let's get the old scissors out so we can perforate it nicely so we can scan it later, as they say. That was number 7. So 7x minus 3 and negative 3x plus 9. Yes. So we're going to do addition first. So I'm going to put these in parentheses just to show that we're adding each of these binomials. That to get rid, you distribute the positive 1, which gives you 5a minus 2 plus 6a minus 1. 5a plus 6a minus 2 minus 1 gives us 11a minus 3. B is subtracting. You have the same two binomials. The only difference is the notation. Instead of adding them, we are subtracting them. And we're going to distribute a -1 into both of those terms. That becomes negative 6a plus 1. Now we're going to put them next to each other, like terms in standard form. And that is negative a minus 1. We have 11a minus 3, negative a minus 1. Very nice. All right, now they're getting a little bit more. We're going to write above and below. So we have the quantity x squared minus 2x plus 1. Also a good opportunity to make sure that your polynomial is in standard form. It'll just help you. So we'll distribute that positive 1 into each of them, which doesn't do anything other than removing the parentheses. We need to remove the parentheses so we can move them across and use the associative property, or excuse me, the commutative property, and that allows us to align or put our like terms next to each other. And that'll be 4x squared, these cancel, plus 5. So that should be the correct answer, 4x squared plus 5, good. And now we're going to subtract. So as I said, I'm going to move it down. This time it's subtracting that trinomial, 3x squared plus 2x plus 4. And when we distribute this negative in order to get rid of the parentheses, that will change the sign of each of the terms in here. So we had a positive 3x squared, it's now negative 3x squared, minus 2x minus 4. Let's write them in standard form and combine like terms. Minus 2x squared minus 4x minus 3. That is, what number is that? That's negative 2x squared minus 4x minus 3. Yep. Oh, this is good. So this is a trinomial. This is A, addition. Parentheses, 5x squared plus 2x plus 3 plus a binomial. Only two terms. 5x squared plus 2x plus 3 plus x squared minus 7x. 5x squared plus x squared plus 2x minus 7x plus 3. 6x squared minus 5x plus 3 would be our answer. 6x squared minus 5x plus 3. Part B is to subtract those two polynomials, 5x squared plus 2x plus 3 minus x squared minus 7x. Always good to write out. Don't feel like you have to skip steps. I'm moving at a pretty fast pace and writing this work out in order to ensure accuracy isn't the worst thing. It's not taking up so much time that you're not going to be able to get done or get through your material. So this is 4x squared plus 7, 8, 9x plus 3. So 4x squared plus 9x plus 3. There's a balance. You definitely want to cut time. You want to be efficient, but not to the expense of accuracy. So accuracy for Mr. McCausland involves writing things out. That's just the way I am. I need to see it. I want to be able to go back. Oftentimes, writing it, my subconscious will find the mistake, or I'll feel that I had made a mistake somewhere. Like in this problem, I'm feeling, ooh, did I do it right? I noticed something's different about this. No, I'm good. I haven't made a mistake yet. It's coming though, I can feel. I will make a mistake some point here in this lecture. It's just the way it is. X to the third plus x squared plus 5x plus 1. B, we're going to take those two polynomials. Polynomials is a very general. It's not specific to the number of terms. Poly meaning many. We're going to distribute that negative. So we get x third minus 2x squared minus 3x squared minus 5x minus 1. X cubed minus 5x squared minus 5x minus 1 should be the answer to B. X cubed minus 5x squared minus 5x minus 1. Yes. A, quantity of 4x squared plus 3x minus 6 plus the quantity. Whenever you see the parentheses and there are more than one term, we would call that the quantity. 4x squared plus 3x minus 6 plus 5x plus 8. Let's put them in order. Let's get the x's together. Let's get the constants together. 4x squared plus 8x minus, plus 2. That is number 12. 4x squared plus 8x plus 2. And now let's take those and subtract them. 5x plus 8. 4x squared plus 3x minus 6 minus 5x minus 8. 4x squared plus 3x minus 5x minus 6 minus 8. 4x squared minus 2x minus 14. 4x squared minus 2x minus 14. These are all good. Hopefully, at this stage, you should be very, very proficient at this. And so now we're pushing for efficiency, speed, where we're doing it not sort of thinking. We're just, there was a mistake almost. We're just getting through it because we're so familiar with it. We know what the steps are and what we're doing. And so our work is pretty efficient. Coefficients, doesn't have a pair, and then 3. So 13, 8x squared plus 4x plus 3. These are good. Everything should be. And when you are checking this against my work, you should be writing all this down and comparing your notes with my notes, my steps with your steps. Your next line should look identical to my next line. And then you should be writing these things. And if there's a difference between answers, what we're able to do is we're able to look at that line and see where the difference is, and hopefully we can catch our mistake. That's why we write it all out. If we don't write our work out, then we can't see where our mistake might be. You can't go through your conscience if you're doing it in your head. That's not a great place to show work, because your retention, Mr. Mac almost made another mistake. Haven't made one yet. I'm getting there though. I'm talking a lot and I'm not paying attention. So we get x cubed plus 2x squared minus 3x plus 2 plus 3x cubed minus 2x squared plus 4x minus 5. Let's put them in order. X cubed plus 3x cubed plus 2x squared minus 2x squared minus 3x plus 4x plus 2 minus 5. Coefficients gives us 4x cubed. The 2x squared minus 2x squared cancel. Negative 3x, positive 4x gives us a positive. We would never write 1. We don't write positive 1x. We just write plus x minus 3. 4x cubed plus x minus 3. Now b, we're going to subtract those big polynomials. 3x plus 2 minus the quantity. 3x cubed minus 2x squared plus 4x minus 5. Distribute that negative out, we get x cubed plus 2x squared minus 3x plus 2 minus 3x cubed plus 2x squared minus 4x plus 5. Switching the sign for each of the terms inside there. Let's match them up. X cubed minus 3x cubed plus 2x squared plus 2x squared minus 3x minus 4x plus 2 plus 5. There's a lot of. So negative 2x cubed plus 4x squared minus 7x plus 7. Check that one. Negative 2x cubed plus 4x minus 7x plus 7. Nice. We're good. Okay, this is just multi-stepped. So we see that we have a monomial times a binomial. We can't combine those because those are unlike terms. So that's why we have to simplify through distribution. We're going to, something important with this one, we're going to distribute the negative 3x, and we are going to distribute it to both of these terms. We can't combine either of these. And then we've got this constant out here that we will attach later. So you see 4x times 3x, 4x times 2. When we distribute, it's 4x times 3x, 4x times 2, negative 3x times 2x, negative 3x times negative 1, minus 4. And then we put them in standard form, we combine like terms, and we put it in descending order. So we're going to distribute this 4, because that says 4 times. We're going to distribute it to all 3 terms, 1, 2, 3 terms. And then we have this term that we're going to distribute out to each of those. Same thing. So we have 4 times 2a squared plus 4 times 3a plus 4 times negative 2 plus 2 times a squared plus 2 times negative 6. That's a negative 6, that's an a squared. Seeing those terms. So when we multiply 4 times 2a squared, number times number, variable times variable, so there's no other variable. 4 times 2 is 8a squared. We have 4 times 3, which is 12a. 4 times negative 2 is negative 8. 2 times a squared is 2a squared. 2 times negative 6 is negative 12. I'm going to rewrite them in descending order because I like taking 4 seconds, 3 seconds, so I know what I should get, and I'm writing it correctly. So 15 goes back to that one. So let's take a look-see. 15 should be 10a squared plus 12a minus 20. We are good to go. So we're going to distribute this 3 into each of the 3 terms. 3 times x squared plus 3. We have to have that plus to show the separation between terms, times negative 3x plus 3 times 4. I see students not putting this sign in front of that term that's being distributed. We're distributing a positive 3. And here we're distributing a negative 2 to 3x squared, and a negative 2 to negative 4x, and a negative 2 to negative 1. So 3 terms. We see our 3 terms here, and we see what we're distributing, a negative 2 to each of those 3. So 3x squared minus 9x plus 12 minus 6x squared plus 8x plus 2. We're going to rearrange so we can see with our eyes and be able to go back and check if we get an answer that is conflicting. So negative 3x squared, that's the other thing that writing our work down, if we get an answer for 16 that is different than what we have written, we can go back and look at each of the steps and we can find our mistake because we did very detailed description. Negative 2x squared plus we're distributing a 4 to x to the 4th. We're distributing a 4 to negative 3x cubed. We're distributing a 4 to 2x squared. That's 2x cubed minus 4x squared plus 4x to the 4th minus 12x to the 3rd plus 8x squared. We got this x to the 4th that's trying to sneak in there, plus 2x to the 3rd minus 12x to the 3rd minus 4x squared plus 8x squared. What happens often is they'll skip a term or it'll be missing. It won't go complete descending order. And we just have to be careful of not losing it, meaning it's hidden. So that's going to be plus 4x squared. So 17 should be 4x to the fourth minus 10x third plus 4x squared. All right, I think this is the last problem, so hopefully we can go 100% and not make any mistakes, which would be good. And that's our goal. I just saw a putting short or video where that person is practicing putts around the hole, and they have to get like 20 in a row. And if they don't, then they have to start back from the beginning. So that repetition and that doing it over and over and over provides you repetition. That repetition provides you accuracy, speed, and consistency. Now we're going to see if this is the case, because Mr. Mac was talking the whole entire time and he wasn't completely able to follow and ensure. So here's another thing that we should keep in mind is don't talk, don't do other things when you're doing your work. If you want to be accurate, you want your focus to be on your work, but it's correct. Oh yeah, baby. All right, that's 4-1. Dealing with polynomials, adding, subtracting, degrees, standard form, putting them in order.